This video will describe how to find the location of a vacuum leak in a Labconco freeze-dry system. The freeze dryer should reach a vacuum of 0.133 millibar within 10 minutes and should achieve an ultimate vacuum of 0.040 millibar within 18 hours. Here are a few things to check before diving deeper into the troubleshooting process. Inspect gaskets for cracks or defects. Ensure all gaskets and sealing surfaces are clean. Make sure the quick connect drain fitting is disconnected from the drain port. Check the 0.75-inch vacuum tubing connections to the pump and freeze dryer for proper clamp positioning and tightness. Each cut end of the tubing has a small slit in the vinyl material. If the hose clamp is installed on top of the slit, it could cause a leak. If necessary, move the clamp slightly away from the end of the tubing and retighten. Make sure all sample valves are in the closed or vent position. If you have a vacuum pump that requires oil, check the fill level and condition of the oil. Make sure the oil is filled to the proper level, as indicated by the markings on the pump, and that the oil is clean and clear. If the oil looks cloudy or has any particulates, replace the pump oil. A second vacuum gauge capable of reading 0.003 millibar may be required to determine if the vacuum pump is good. Isolate the pump by disconnecting the vacuum hose from the freeze dryer. Insert the vacuum sensor from the secondary vacuum gauge into the vacuum hose and secure with a clamp. Confirm the pump is capable of achieving an ultimate vacuum less than 0.020 millibar. If the pump does not achieve this vacuum level, it may need to be replaced or rebuilt. Ensure the collector coil, chamber, and drain line are completely dry, since any moisture or other solvents left behind from previous processes will affect the vacuum level. Let's talk about a couple techniques that will help to isolate the vacuum issue. A fundamental method in vacuum troubleshooting is to divide the system into smaller sections and determine which side contains the issue. Another technique is using alcohol to detect small vacuum leaks. One of the most useful tools for finding small vacuum leaks is a laboratory squeeze bottle filled with an alcohol such as methanol or ethanol. The principle behind this method is that when liquid alcohol is pulled into a vacuum chamber through a leak area, it immediately vaporizes and increases the pressure in the chamber, which causes a rapid increase, or spike, in the vacuum reading being displayed. For this technique to work, the system must be under vacuum and able to achieve a vacuum level that is within the range of the sensor. When checking for leaks with alcohol, try to check connection points one at a time and allow 10 to 20 seconds for the vacuum gauge to respond before moving on to test the next connection. If you are testing an area where the alcohol could run downhill and cover multiple connections at the same time, start from the bottom and work upward. A freeze-dry system normally consists of a freeze dryer and a drying accessory, such as a multi-port manifold or drying chamber. Let's start by separating the drying accessory from the freeze dryer. For benchtop freeze dryers, remove the drying accessory, but replace the lid and flat gasket on the collection chamber and cover with a large freeze-dry flask. An acrylic cap can also be placed on the flat gasket to seal off the 3-inch hole in the acrylic lid. For console freeze dryers, several methods can be used to seal off the 3-inch vacuum port. A large freeze-dry flask can be placed on the gasket. A number 8 rubber stopper can be placed in the 1.5-inch pipe inside the 3-inch vacuum port. The vacuum port can also be sealed by using a flat gasket, acrylic spacer, a second flat gasket, and an acrylic cap. After sealing off the 3-inch vacuum port, turn on the vacuum and allow the vacuum reading to stabilize. If the vacuum reading is good, then the problem is in the drying accessory. If the vacuum reading is still not satisfactory, then the problem is in the freeze dryer or vacuum pump. Let's look at the drying accessory before moving on to the freeze dryer. Make sure all valves are in the closed or vent position. Check for loose fittings on 12 and 16-port stainless steel drying chambers. If the leak is small enough that you are able to get a vacuum reading on the freeze dryer display, rotate the rubber body of each valve and watch for any fluctuations in the vacuum reading. Spray the flat gasket seal at the chamber wall and the joints between the rubber valve body and plastic parts. Turn the valve inlet vertical and add a few drops of alcohol in the opening. If a valve is leaking, or the valve knob is hard to turn, you may need to disassemble and service the valve. If you are not able to fix a leaking valve, it may need to be replaced. You can also remove the valve, stopper the hole, and move on to inspecting other valves if necessary. Now let's look at the freeze dryer. Let's divide the system into smaller sections again by removing the collector chamber lid and placing a stopper in the vacuum port on the inside wall of the collector chamber. Turn on the vacuum and allow the vacuum reading to stabilize. If the vacuum reading is good, the problem is in the collector chamber or drain line plumbing. If the vacuum reading is still not satisfactory, the problem is in the vacuum pump or plumbing between the pump and the stoppered hole. The following connections should all be checked with the stopper still in place in the collector chamber and the vacuum turned on. Start with the most easily accessible connections, which are the 0.75-inch vacuum hose connections, to the vacuum pump and freeze dryer. For console models, you will need to remove the front panel or lower rear panel for access to all connections. Console models with purge valve option have a few more vacuum hose and pipe thread connections to check at the valve. For benchtop models, you will need to remove the back panel to check the remaining connections. Check each of the 4 connections to the rubber coupling one at a time. When vacuum troubleshooting in this area, the collector should always be turned off, so that the fan blade is not spinning, and a cloth should be placed over the sharp edges of the condenser fins. If you find a leak at the connection to the vacuum control valve, check to see if the valve is fastened tightly against the adapter. This is a threaded connection with an O-ring seal between the valve and adapter. If the vacuum reading was not satisfactory when the 3-inch vacuum port was sealed off, but the vacuum reading was good, with the stopper in the vacuum hole on the inside wall of the collector chamber, you will need to look at the collector chamber and drain line plumbing. The front panel will need to be removed to access these connections for benchtop and console models. Remove the stopper from the vacuum port inside the collector chamber. Replace the collector chamber lid. Seal off the 3-inch vacuum port. Then start the vacuum and allow the vacuum reading to stabilize. Starting from the bottom of the drain line, check the quick connect valve seal by spraying alcohol into the open end of the drain port. Then continue to the lower hose clamp connection. Check the connections to the moisture sensor. There are 2 hose connections and 2 threaded fittings with an O-ring seal. Check the hose connection to the drain spud at the center of the collector chamber. For console models, there will also be a rubber coupling connecting the collector chamber to the 3-inch vacuum port. Check each end of the coupling with alcohol and readjust and tighten clamps as needed. For further assistance, please contact the Labconco product service team.